Okay, here's question 19 on version B. And they want to know which statements are true, and it's possible to have more than one answer. Okay, so it says AF and DH. AF and DH are right there. Here, I'll actually draw them. AF and DH right there. Well, right now there's no marks, so we don't know. But if you do a little bit of thinking, this and this are vertical angles, and now the triangle ACF is congruent to the triangle DCH by SAS. So we've got this side matching up with this side matching up with this side. Okay, and then you've got the angle, so that's SAS. And when you do that, that means now you can say, so it actually is true that AF is congruent to DH by corresponding parts on congruent triangles are congruent. So the yellow pieces match up here. Okay, so we've got that going on there. So that was true. Okay, the next thing I want to check is DH and BH the same. DH and B to H. And it turns out no. DH is not congruent to BH. Okay, that's not true. When you look at it there, I mean, the lengths are clearly not the same, but also the markings. All we know is that this is the same as this, but this distance here, it's on a diagonal. It would have to make a make a triangle with that, and that means that's the hypotenuse. B to H is the hypotenuse. It's always longer than any of the legs. So I don't think so. Okay, so we got that one is wrong. And then it says angle ADC, A to D to C. This angle here is congruent to angle C to H to J. C to H to J. We really don't have any information for those triangles. We don't know anything about the triangle. There's not enough info, so that would be wrong. Angle ADC is congruent not to angle CHJ. Okay, so we got those ones there. There's nothing to show that there. We just don't have enough matching up stuff to be able to say angles and sides are the same and all that. There's just not enough information. I highly doubt it as well. And then the last one is angle ADC. So let's do that in red. A to D to C. We already just mentioned that. So we've got already in green. Angle ADC. So that's this one right here. Okay. To angle DAC. So they said D to A to C. Well, it turns out yes. They're opposite it's an isosceles triangle. So it turns out that's true as well. ADC and DAC. Remember by the base angles theorem. An isosceles triangle, the angles opposite the sides that are the same are also the same.